In this example, we want to convert a complex number into exponential form and use that to find the exponential form of the conjugate as well as the product of the different complex number. So our first task here is to take the complex number given here, minus 2 root 3 plus 2i, and convert that into exponential form. So this we can see that the modulus, or the absolute value, or the length, is going to be square root of x squared plus y squared. This is 2 square root of 3 squared plus 2 squared. 2 square root of 3 is the square root of 12. This is square root of 12 plus 4, or 16. So this is 4. And for the angle, the theta will be the inverse tangent of y over x, which is the inverse tangent of 1 over root 3 with a negative sign. That means that sine is 1/2 and cosine is root 3 over 2. So that gives it this angle here is negative pi over 6. But that's not the correct angle for this complex number because this number here is in the second quadrant. It is x coordinate negative, y coordinate positive, it's in the second quadrant. This angle here is in the fourth quadrant. So to get to a matching angle in the second quadrant, we have to add pi to this. So our angle here is actually 5 pi over 6. So for this, we have that the complex number, negative 2 root 3 plus 2i, is 4 e to the I times 5 pi over 6. Now, for the conjugate, we could solve this in two ways. We could either just take the fact that the conjugate complex number is minus 2 root 3 minus 2i and solve it directly, or we can use geometry here. And for the geometry point, we realize that when I take the complex conjugate, so minus 2 root 3 plus 2i is somewhere around here, the complex conjugate will flip over the x-axis and end up down here in the third quadrant. If this is z, then this is z bar down here. Now we could use the fact that we know that because of reflection, these two angles are the same in magnitude to get what the angle should be, or the fact that this angle is the same as this angle down here. So what that means is that when I take the complex conjugate, I'm taking the same angle theta of the rotation that I have up here and doing it in the opposite direction down here. So since this will have the same magnitude, but the opposite angle, we then know that we can write z bar as 4 e to the negative I times 5 pi over 6, or by adding 2 pi to the angle, 4 e to the I times 7 pi over 6. Either of those work for writing out what this complex number is. And now lastly, we want to multiply this number z, this first one here, by 1 plus I. So 1 plus I in complex form is going to have radius of square root of 2. Right, the radius here should be square root of 1 squared plus 1 squared is root 2. And the angle should be inverse tangent of 1 over 1, or pi over 4, because we are in fact in quadrant 1. So therefore, taking this fact, we would get that 1 plus I times z is 4 e to the I 5 pi over 6 times root 2 e to the I pi over 4. And with this, I can just multiply the r values, so I get 4 root 2 in front, and add the angles. Now 5 pi over 6 plus pi over 4, this is 10 pi over 12, this is 3 pi over 12, gets me e to the I times 13 pi over 12. And that would be the product there. We could convert that back into standard form, or rectangular form, by writing out cosine of 13 pi over 12 and sine of 13 pi over 12, but those aren't special angles. There's no real need to write that out. We can leave our answer here in this exponential form. That's how you would set up and solve the different problems involving the exponential form of complex numbers.